NENOMATICA, where mathematics meets YouTube excellence. Welcome to this lesson on solving first-degree linear equations in more than one variable. In this video, we'll learn how to solve an equation for a specific variable when there are multiple variables present. The most important aspect of solving these equations is determining which variable we want to solve for. Let's look at an example to understand this better. Let's solve this step by step. Step 1. We'll start by expanding the right side of our equation. The equation a equals p times the quantity 1 plus rt can be rewritten as a equals p plus p times r times t. Step 2. To isolate the term containing our target variable r, we need to move all other terms to the other side. So we subtract p from both sides of the equation. Step 3. Now we need to isolate r. We can factor out the constant terms p and t. This gives us a minus p equals p times r times t. Step 4. To isolate r, we need to divide both sides by p times t. This gives us the fraction a minus p over p times t equals r. Step 5. As our final step, we can rewrite the equation with r on the left side. Therefore, r equals a minus p over p times t. Let's summarize what we've learned. To solve for a specific variable in a linear equation with multiple variables, first, identify which variable you're solving for. Next, isolate the term containing that variable by moving all other terms to the opposite side of the equation. Then, if the variable is multiplied by constants, divide both sides by those constants to isolate the variable. Finally, write the solution with your target variable on the left side. This technique can be applied to any linear equation, regardless of how many variables it contains. Today we're going to solve for unknown variables in algebraic equations by isolating them step by step. Let's start with our first problem. In this example, we need to find the value of capital R from the equation V equals m times the quantity 1 over b minus 5a r over m. We're told that R equals question mark, meaning we need to solve for R. Let's start solving for capital R. First, we'll distribute m to the terms inside the parentheses. This means we multiply m by 1 over b, and we multiply m by negative 5a r over m. For our next step, we'll multiply both sides by b. We multiply v by b to get vb, and on the right side, we multiply m over b by b to get m, and we multiply negative 5a r by b to get negative 5abr. Next, we'll subtract m from both sides. On the left side, we get vb minus m, and on the right side, we get negative 5abr. Now we'll divide both sides by negative 5ab. On the left side, we get vb minus m divided by negative 5ab, and on the right side, the negative 5ab are divided by negative 5ab simplifies to just r. We can simplify this further by factoring out the negative sign from the denominator. When we move the negative sign to the numerator, we get r equals negative vb minus m divided by 5ab. We can further simplify by distributing the negative sign to the numerator terms. When we distribute the negative, we get r equals negative vb plus m, all divided by 5ab. Finally, we can rewrite this in the desired form as r equals m minus vb, all divided by 5ab. Now, let's move on to our second problem. We have the same equation, but this time we need to solve for b, where b equals question mark. Just like before, we'll distribute m to the terms inside the parentheses. Now, we'll add 5ab, r, to both sides of the equation. On the left side, we get vb minus m plus 5abr, and on the right side, we get 0. We'll rearrange this equation to isolate terms with b. We get vb plus 5ab, r equals m. Next, we'll factor out b from the left side. We can pull out the common factor b from vb and 5abr, which gives usb times the quantity v plus 5a, r equals m. Finally, we'll divide both sides by v plus 5a, r to isolate b. This gives us our final answer, b equals m divided by the quantity v plus 5ar. We have the equation 1 over a equals 1 over b plus 1 over c, and we need to find the value of c. Let's apply a common technique for equations with fractions. We'll multiply both sides of the equation by abc to eliminate the denominators. Now let's distribute abc to both terms on the right side. Let's rearrange the equation to isolate the terms with c. Now we can factor out c from the left side of the equation. Finally, we can solve for c by dividing both sides by the term b minus a. Now, let's move on to our second example. We have the equation y equals 4 divided by the quantity 5x minus 9, and we need to find the value of x. Let's multiply both sides by the denominator 5x minus 9 to eliminate the fraction. Now we can distribute y to each term inside the parentheses. Let's rearrange the equation to isolate the term with x. Finally, we can solve for x by dividing both sides by 5y. Let's start with the first example. In this first problem, we're given an equation y equals 4 minus 3x divided by 1 plus 8x, and we need to solve for x. Let's follow the step-by-step solution. First, we need to clear the denominator. Now, let's expand the left side of the equation. Now, we'll rearrange the equation to get all the terms with x on one side. Next, we'll factor out x from the terms on the left side. Finally, we can solve for x by dividing both sides by the coefficient of x. That's our answer. We can simplify this to get x equals 4 minus y divided by 8y plus 3. Now, let's move on to our second example. In this second problem, we're given an equation E equals 3v times the quantity 4 minus 2 over r, and we need to solve for r. Let's follow the step-by-step solution. First, we'll expand the expression on the right side. Now, let's multiply both sides by r to clear the denominator. Next, let's rearrange the terms to isolate r. Now, let's factor out r from the left side of the equation. Finally, we can solve for r by dividing both sides by the coefficient of r. And simplifying, we get our final answer. R equals negative 6v divided by e minus 12v. We have the equation q equals 6h divided by 7s plus 4 times the quantity 1 minus h. We need to find the value of s. Let's solve this step by step. First, we'll multiply both sides of the equation by 7s to eliminate the fraction. We get q times 7s equals 6h plus 7s times 4 times the quantity 1 minus h. Now, we distribute 7s to each term in the parentheses. This gives us 7s times q equals 6h plus 28s times the quantity 1 minus h. Let's expand the right side of our equation. We get 7s times q equals 6h plus 28s minus 28s times h. Now, let's rearrange to isolate the terms with s. We get 7s times q minus 28s times the quantity 1 minus h equals 6h. Next, we factor out s from the terms on the left side. We get s times the quantity 7q minus 28 times the quantity 1 minus h equals 6h. Finally, we solve for s by dividing both sides by the coefficient of s. This gives us s equals 6h divided by the quantity 7q minus 28 times the quantity 1 minus h. Now, let's move on to our second problem. We have the same equation as before. Q equals 6h divided by 7s plus 4 times the quantity 1 minus h. But this time, we need to find the value of h. We'll follow the same initial steps as before. First, multiply both sides by 7s to clear the fraction. This gives us q times 7s equals 7s times the quantity 6h divided by 7s plus 4 times the quantity 1 minus h. Next, distribute the 7s. We get 7s times q equals 6h plus 28s times the quantity 1 minus h. Now, let's expand the right side of our equation. We get 7s times q equals 6h plus 28s minus 28s times h. Now, let's rearrange the equation to group the terms with h together. We subtract 28s from both sides to get 7s times q minus 28s equals 6h minus 28s times h. Now, let's factor out h on the right side. We get 7s times q minus 28s equals h times the quantity 6 minus 28s. Finally, we solve for h by dividing both sides by 6 minus 28s. This gives us h equals the fraction 7s times q minus 28s divided by 6 minus 28s. Let's start with our equation. We have a minus 1 minus 2t divided by 4p equals 4 plus 3t divided by 5p, and we need to find the value of t. For our first step, we need to eliminate the fractions by multiplying both sides by the least common multiple of the denominators. In this case, the denominators are 4p and 5p, so we'll multiply both sides by 20p. Next, we distribute the multiplication. On the left side, 20p times a gives us 20ap. Then we have 20p times negative 1 minus 2t divided by 4p. Simplifying this, we get negative 5 times 1 minus 2t. On the right side, we have 20p times 4 plus 3t, all divided by 5p, which simplifies to 4 times 4 plus 3t. Now, let's expand the expressions. On the left side, negative 5 times 1 minus 2t gives us negative 5 plus 10t. On the right side, 4 times 4 plus 3t gives us 16 plus 12t. Let's rearrange the terms to group like terms together. We move all terms with t to the left and all other terms to the right. So 10t minus 12t goes to the left side, and we move negative 5 to the right side, which becomes positive 5. Finally, we can solve for t. We divide both sides by 2 to get t equals 20ap minus 21 divided by 2. And there we have it. We have found that t equals 20ap minus 21 divided by 2. This is our final answer. In this video, we solved for the variable t in an equation. Let's summarize what we did. First, we multiplied both sides by 20p to clear the fractions. Next, we distributed and expanded the terms. Then, we rearranged terms to isolate t. Finally, we divided both sides by the coefficient of t to find our answer. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.